Given this problem statement, let a subscript of n be the nth term of decreasing infinite geometric progression. If the sum, that is a1 plus a2 plus a3, if this is equal to 52, and then the product of a1 a2 plus the product of a2 a3 plus the product of a3 a1, that is given as 624. So in that case we need to compute the sum of this geometric progression. Now proceeding towards the solution, so let us make an assumption here. Let the first term of the geometric progression, let me represent it by a, and the common ratio, so this one I'll represent it by r. So let this be represented by this letter r. So now in this problem statement, it's already given that sum of this a1 a2 a3, this is given as 52, and this further implies this is a multiplied by 1, and 1 can be written as r to the power 0, considering that r is non-zero, right? Plus a r to the power 1 plus a r to the power 2, that is a r square. This is equal to 52, right? And on resolving this part, so maybe I'll just write this in the next line, right? And this further implies, that is, I can take a as the common factor, and this is 1 plus r squared, that is equal to 52, and we'll see later where we can use this particular piece of information. So from this we can say, if I just isolate this a, this can be written as 52 over this particular quantity, right? Now, and the next one that is given us, that is this part, right? The next part. So this further implies, maybe I'll just write it in the next line. So this further will imply a subscript of 1, and then it is multiplied by a subscript of 2. So this one I will write it as a square times r plus a square times r square plus, and here a square times r to the power 3. Now this is equal to 624, right? So here these I'm just taking these assumptions and substituting here, right? So that is a subscript of 1. So in this case I have just considered, that is a subscript of 1 here. So from this a times r power 0, and then for this a subscript of 2, so for this one I have written a and then r power 1. So that is effectively a square r, and similarly for a2 a3, and then for a3 times a1. So now we have this quantity with us. So now I'll just proceed to the next part. So once we have got this 624, now let us proceed towards the next steps. Now this further implies, so I'll just take this one and repeat this once here. Now in the next step I'll be writing here. So from here you can observe that a square is common, and this is r, the common factor a square, r plus, this is r square plus r to the power 3, and this is equal to 624. Now in the next step, so here this value of a here, that is a square here, so I'll take this particular value, that is 52 over 1 plus r square. So let me just replicate this part, and this a I'll replace it here, right, at this particular position. So this becomes a square times this. Now I'll be resolving this part because I have a single variable over here. On resolving this part, this becomes r over 1 plus r square, right? So this will be equal to 3 over 13 once this particular step is resolved. Now we have a quadratic equation clearly in front of us. So this can be written as 3r square minus 10 times r plus 3, that is equal to 0. Now from this one, this can be factorized into linear factors. So 3 times r, then minus 1 multiplied by r minus 3, that is equal to 0. Now from this part we can clearly mention that r belongs to the set, that is 1 over 3 and 3. So these are the two distinct roots, right? Now for an infinite geometric progression as it is mentioned in the problem statement. Now, from this we can definitely mention here that for an infinite geometric progression, so here definitely the absolute value of the common ratio is less than 1, right? So from this we can say that for R the only selected value will be 1 over 3, right? So now moving ahead, this A which we already have here, the value of A, that is 52 over 1 plus R square. So this one I will replicate, and in place of R I will replace it by 1 over 3. So this is 1 over 3, and on this part also this will be 1 over 3. On resolving this part I will be getting 36. So finally the value of A is 36 over here. So the sum which I will represent by S of infinite geometric series is the first term over 1 minus the common ratio, right? Now this can be written as first term, that is A, 36 1 minus R, that is 1 over 3. On resolving this part I will be getting 54. Hence for this problem statement 54 is the correct answer, right? So this is the solution and its answer as 54, and this is the given problem statement.